So we see these questions. Find Thevenin equivalent circuit. Assume the load will be connected between point A and point B, and find the current going from point A to point B if we have 4K resistor connected between A and B. So find the Thevenin equivalent circuit means we need to find what is the VTH and the RTH. So we can first find the VTH value. Okay, let's say I'm going to find the VTH values over here, meaning that this VTH is equal to VA minus VB. Okay, so what is a VA? So the VA actually is a series circuit which this one's connected to 12 volt. So that means we know that from this point to the ground here, this gives us 12 volt. So this is a voltage divider circuit. That means the VA can be calculated as 12 volt. Okay, then times the R2, which gives us 4K. Okay, then divide by the series resistance 2K plus 4K. So this gives the VA. Okay, and then we substitute what is the VD, we find VB. So VB also is the same. The supply voltage is 2 volt, is 12 volt, and then divide by 4K, and then we have 4K plus 8K. Okay, so we're going to substitute this value here. What is the VTH in this case? Okay, so in this case we have this VA minus VB. So you calculate the above value for the VA and the VB. Then this one is going to get us 8 volt. We calculate this you're going to get us 4 volt. Okay, so in this case we have 8 minus 4. So we get a 4 volt for the VTH value, right? Okay, now we're going to find the RTH value. Find the RTH, terminating resistance. So RTH value, we can redraw the circuit here. So for the redraw the circuits, the ideal voltage source is replaced with ideal wire, and then we're going to connect to this resistor here. This is our R1, and then we have this node A, go to this R2, and then we have this node B here, connected to resistor 3, and then go to 4. Okay, so what is the RTH between the A and B in this circuit? Okay, so we can redraw this. Let's say we're going to start from this A node here. This is our A node. For instance, A node is split into two paths, which is the R1, and here is R2. Okay, so at the end of this terminal over here, they will be connected together. After they connected together, they will go to where? They will go to the R3 and R4. So that means they will connected together. Okay, so in this case, what we can see, we have split another path here from this, which is R1 connected to the R3 on this side, and R2 connected to the R4. Okay, and then this one connected together, go to the junction node B. Okay, so the RTH value will be equivalent to R1 is parallel with R2, and then these two are then plus series with R3, and then is parallel with R4. Okay, so in this case we can substitute the value. What is the R1 values? R1's value, we can substitute either value. This is the 2K, and then this is a 4K, here is 8, this is the 4. Okay, we're going to substitute value. So R1 is 2K, so that means 2K parallel with 4K, then plus R3 is 8K parallel with the 4K. Okay, so we have 2 times 4, 2 plus 4 plus 8 times 4, 8 plus 4. Okay, we're going to add up this. Then you're going to get the RTH value. And this RTH value equal to 4 kilo ohm. Okay, so we have the RTH value and the VTH value is 4 volt. So we can draw the Thevenin circuit here. Okay, we draw the Thevenin circuit, which is a series circuit, consists of Thevenin voltage, VTH. So VTH here is equal to 4 volt, and then connect with a series resistor, and that resistor we call it as the RTH, and this value is 4K. Okay, so we have this A0, and then here we have this V0 here. Okay, so that is the Thevenin's equivalent circuit. Okay, and the next things we want to find out is the what is the current flow through 4K resistor. Okay, 4K resistor if connect between A and B. So between A and B here, we have this 4K resistor. Okay, we're going to connect to this Thevenin equivalent circuit. Okay, to find the current. So let's assume that the current flow in this circuit denoted as I. So what is the I value? So the I value we're using the Ohm's law, which is the VTH 4 volt divided by total resistance here, which is 4K plus 4K. So your I is 4 divided by 8K. So we get 1 over 2 amperes. So it's 0.5 milliampere. Okay.